to take a look at liquid carbon dioxide. Now, not many people have seen liquid carbon dioxide, so I hope you pay attention. It's funny that we have never seen liquid carbon dioxide because you're probably around it quite a bit. Any carbon dioxide fire extinguisher that you have or may have seen has inside the big red steel tank, there's liquid carbon dioxide. Or if you've ever seen a soda machine, they have the gray steel tanks containing liquid carbon dioxide to carbonate your beverages. But both of those are under very high pressure, and so they keep them in steel tanks that you can't see through, so you haven't actually seen the liquid carbon dioxide. Well, when you think about it, if you get carbon dioxide very cold at atmospheric pressure, it turns into dry ice, which I've got some here. I have some crushed dry ice. I'll get out a small piece. And so solid carbon dioxide we call dry ice. Let's see if I can get a piece. There's a piece. A little piece. And we call it dry ice for a good reason. Let's do a thought experiment. Normal ice, if I took an ice cube, a water ice, and put it out on the table and came back in an hour, there'd be a puddle of water. But dry ice is dry. At atmospheric pressure, it changes from a solid directly into a gas. We would call that subliming. That's where it gets its name from. It's not wet in the sense that it doesn't make a puddle, it doesn't melt at atmospheric pressure. However, that's because atmospheric pressure is below its critical pressure. However, if we can increase the pressure to above its critical pressure, we can actually see liquid carbon dioxide. So we've devised this apparatus right here. In here we have, let me get a little bit closer so you can see it. We have a high pressure vessel that I can take off and put some of the powdered carbon dioxide into that, seal it up. Here I have a valve that I can open or close or open. And here we can keep track of the pressure. This is an emergency release valve in case the pressure gets too high. So we're going to put some crushed dry ice in here, stick it into this vessel that's going to have some water in it. We're going to use water to warm it up because dry ice is about -95 degrees Celsius, so water is a good way to warm it up. That will warm it up, and we'll see what happens. We'll close the valve and see what happens to the pressure. You ready? I suppose I should get some water in here. Here's some water in my vessel. This tube so that we can see through it. That's regular tap water. Now I'm going to put some warm water from my teapot into it because it makes it go faster. Makes the experiment, the demonstration go faster if you use warm water. So again, now we have some crushed dry ice. I'm going to put it in here. Put it in the water and close the valve. Now let's see what happens. I'm going to move it a little bit closer so we can see it. And you can see the pressure starting to climb. Pressure is increasing. What's happening is that crushed dry ice is subliming as it heats. And since we have the valve closed, the carbon dioxide pressure is building up. Now there's a sudden change. And we can see it's starting to get the inside of the vessel wet. And indeed, it's melting and turning into a liquid. So you can see that it's melting and becoming liquid, and you may be able to see small bubbles in there. It means it's boiling at the same time. Now, you rarely see something melt and boil at the same time. It's probably indicating that we're pretty close to the triple point of carbon dioxide. Now, you might want to think, what will happen to this liquid carbon dioxide when I open the valve? It will go back to atmospheric pressure. We know that it cannot exist as a liquid at atmospheric pressure. Is it going to turn into a gas? Or is it going to go back to being a solid? Let's see what happens. You can see the liquid sloshing around there. I'm going to bring it a little bit closer so you can see that liquid. Now let's see what happens. I'll open the valve. It's boiling. It's boiling and then it freezes. And what we end up with is carbon dioxide snow. It became a solid so quickly that it didn't have time to form large crystals, so it looks kind of like a carbon dioxide snow. So it boiled and froze.